Okay, the next unit that we're going to start into is called electrochemistry. Electrochemistry is the study of chemical reactions and their relationship with the electricity that it produces. But before we go into that, we need to go over something that you should have learned back in August, and that's how to assign oxidation numbers or oxidation states. If you'll remember, any element in its elemental phase, like oxygen right here, has an oxidation number of just plain 0. So solid aluminum, 0. Oxidation states of a monatomic ion are exactly that of its charge. For example, fluorine is -1, sodium will be +1, right here and right here. Oxygen is typically -2. There are times where it could be -1 when it's peroxide. So if you'll remember, right here in SO2, oxygen is -2. There's 2 of them. That's a total charge of -4. Therefore, sulfur's charge, its oxidation number, is +4. When combined with a nonmetal, hydrogen has the oxidation state of +1. So in ammonia, hydrogen's +1. There's 3 of them. That's a total of +3. Therefore, nitrogen is going to be -3. And then don't forget the charges need to cancel each other out. So, just to do a couple practice problems. Carbon dioxide, oxygen is -2. There's 2 of them. That's a total of -4. Therefore, carbon must be +4. SF6, fluorine is -1. There's 6 of them. That's a total of -6. Therefore, sulfur must be +6. Now, this is nitrate. Nitrate has an overall charge of -1. So you want the overall charge to be -1 as well. Oxygen is -2. There's 3 of them. That's a total of -6. Therefore, nitrogen must be +5. Okay? All right. So, if I have a situation like copper, and it goes to copper +2, it becomes the copper +2 cation. The only way that copper can become copper +2 is by losing 2 electrons. Okay? I can also have copper +2 turn into solid copper. The only way it can do that is by gaining 2 electrons. Okay? This top process right here is called oxidation. This bottom process down here is called reduction. Oxidation is the loss of electrons. Reduction is the gain of electrons. And we're going to remember that by this little device called oil rig. Oxidation is the loss of electrons. Reduction is the gain of electrons. Okay, so if you'll notice, we'll look at one real quickly. Notice that copper, which has a charge of 0 because it's an element, goes to copper +2. The only way it can do that is by losing 2 electrons. Therefore, copper has been oxidized. Oxygen, which is 0, goes to 2 oxygens, each with a charge of -2. Therefore, the only way that we can do this is, watch how I do this. I've got 2 -2's here, so I have to have 2 -2's over here, or a total of -4. So I'm going to add 4 electrons over here to balance this charge out. Notice that oxygen gained 4 electrons, therefore that's called reduction. Oxidation is the loss of electron, reduction's the gain of electrons. Now notice that this has 4 electrons, this has 2, so I need to take this reaction right here and double it. Upon doing so, I'd put a 2 in front of this copper and a 2 in front of that copper, and that's how you balance these chemical equations. They're not all that easy. Let's do one more easy one though. Let's do this in 2 separate reactions. I'm going to do the magnesium reaction first. Mg turns into Mg+2. The only way it can do that is by losing 2 electrons. That is called oxidation. Mercury plus 2 goes to mercury 2 plus 2, or the mercurous ion. Now the first thing I have to do is balance this. I've got 2 mercuries here, so I'm going to put a 2 right there. That gets me 2 mercuries here. Now my charge is plus 4 here, plus 2 here. So I must add 2 electrons over here to balance that out. And upon doing so, that's called reduction. I ended up putting a 2 right here in front of mercury, and that's the only thing I need to do to balance this reaction. Okay. The last thing we're going to do is balance a little bit more difficult reaction. And anytime you're balancing a reaction in an acidic solution, these are the steps to balancing them. First of all, you want to separate the oxidation and the reduction half reactions. We did that earlier. Then you're going to balance any reactions separately. Balance the element first, except hydrogen and oxygen. Then balance the oxygens by adding water, because these are aqueous solutions. Then you're going to balance the extra hydrogens by adding H positive. And you can do this because these are acidic solutions. Then you have to balance the charges by using electrons. So for example, let's look at this one right here. Okay, I'm going to balance the 2 different reactions that I have here. I'm going to break this up. How about I start with chloride? Chloride goes to chlorine. First thing I have to do is balance this by putting a 2 here. Now to balance the charges, I have 2 negatives here, so I'm going to add 2 electrons here. 2 negatives, 2 negatives. This again is called oxidation. To balance the next one, I've got dichromate going to just the chromium 3 ion. Okay. First thing I want to do is balance my chromiums. I have 2, so I'm going to put a 2 here. Now I've got 7 oxygens, and if you remember, if I want to add oxygen here, I add water, so I'm going to add 7 waters. Now I have 14 electrons here, 14 hydrogens here, so I'm going to add, because it's an acidic solution, I'm going to add 14 hydrogens here. And now I need to balance out the charges. This is plus 6 on this side. This is plus 14 minus 2, that's plus 12. So I'm going to add 6 electrons. And since the electrons are on this side, they've been gained. This is called reduction. Now I've got 6 electrons here, 2 electrons here. Therefore, I need to take this and multiply it by 3. So when you add up this entire reaction, what's going to happen? Well, I've got what? 6 chlorides, 3 chlorines. I've got 14 hydrogens, so yes, you actually have to write out 14 hydrogens. 1 dichromate, 2 in front of the chromium 3, and 7 waters. So the overall reaction is 14 H positive plus Cr2O7 negative 2 plus 6 chlorides goes to 3 chlorines, 2 chromiums, and 7 waters. And that's how you balance a redox reaction.